Welcome to Lesson 11, Equal Groups Word Problems in your Algebra 1/2 textbook. Equal groups. In your book, it talks about using the idea of equal groups to solve multiplication and division problems. And we can have either type with equal groups. We just have to see how it's worded as to which operation to use. And once you solve it, it's always important in this kind of thing to go back and check and see if that answer just makes sense. And if it doesn't, then you probably used the wrong operation. Alright, so the book talks about having school buses and children on the school buses, and it talks about how 42 students can ride on each bus, and that's about right. And let's say there are 12 buses. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's only 10 in our picture, barely, but let's pretend there are 12, and on each one I can put 42 students. Alright, now it says how many students can ride to the game. Well, if I say 42 students can ride in each bus, and I've got 12 buses, well, if one bus holds 42, then two buses would hold 84. How many children would 12 buses hold at 42 each? Well, I can say 42 times 12, and that would be, let's see, 2 times 42 is 84, placeholder 42, 504. 504 students can ride to the game at 42 on each one. Alright, go to the next problem. This is not in your book, but I liked it. I found it online, and I liked it because it gives you the pattern. You have number of groups times number of people in each group equals the total. That's your formula. Alright, this problem says Ryan and his friends shared 27 gumballs. If each person has 9 gumballs, how many persons shared the gumballs in all? Alright, well, we know that there are 27 gumballs total. Okay? And each person has 9. We need to know how many people there were. Alright, well, if we work backwards, like working an equation, if we say, if we divide by 9 on both sides, then we have P equals, and 9 over 9 equals 1, and 1 times P is 1P. 27 divided by 9 is equal to 3. Alright, and we ask ourselves, does that make sense? There were 3 people. 3 people had 9 gumballs each for a total of 27. Okay, that answer makes sense. Alright, go to the next problem. Okay, so let's look at example 2 in your lesson. It says 42 students can ride on each bus. There are 1,264 students who want to go to the game. So how many buses do we need to take all the students to the game? Well, we just saw in a previous problem that 12 buses would take a total of 504 students. So we know we have more than that. So let's see, more than twice as many as that. So we're going to need more than twice as many as 12. Let's find out exactly how many we need. we're going to say 1264 divided by 42, and 42 won't go into 1 or 12, but it will go into 126 about 3 times, and then I multiply 3 times 42 is exactly 126. I subtract 0, and then I bring this 4 down. It goes 0, but with a remainder of 4. Alright, now I know I'm going to need 30 buses, but I'm going to have 4 children left over, and I can't split them up on these 30 buses. So I'm actually going to need a total of 31 buses in order to transport all of these 1,264 students to the game. Okay, let's go to the next slide. Okay, so let's look at your practice problems. The first one, it says 40 kids stood patiently in each line. So I've got a couple of pictures of children standing in lines here, and let's imagine that in each line there are 40 children. There are a total of 35 lines of kids, and we need to know how many kids in all are in these 35 lines. Well, if there's 40 in one, then we could say that in 10 lines there would be 400, but we have 35 lines, so we're going to say 40 times 35, or wait, better yet, let's do it like this. Let's do this offset 0 thing. 35 times 4, and then we'll add a 0 on the end. 5 times 4 is 20. 4 times 3 is 12, plus 2 is 14. So we have a total of 1,400 children if we have 35 lines with 40 in each one. Alright, let's go to the next one. Okay, now use your imagination a little bit on these pictures. I found the best ones that I could find on the web. Practice problem B says 40 kids could crawl into one space, and we're going to look at the box here as a space, okay? And we can get 40. Again, use your imagination. We can get 40 in each space. There are a total of 1,600 kids in all. If we can get 40 into each space, how many spaces are going to be needed? Now in this one, I'm going to use the division algorithm, and I'm going to say 40 spaces and 1,600 children. Alright, 40 will go into 164 times, and that's 160. And when I subtract, I get 0 and 0 and 0. Alright, so it looks like I'm going to need 40 spaces, and then I'm going to check that answer and see if it makes sense. 40 spaces, let's say it's 40 boxes. Let's just pretend, use your imagination, these are really, really large boxes, okay? Times 40 kids in each. 40 times 40 equals 1,600 kids in all. So I have done the right thing. I need a total of 40 spaces. Okay, last one. Alright, C says there were 148 kids that had to be crowded evenly into 8 spaces. How many kids would be in each space? All right, again, so I've got 8 spaces, 8 boxes, and I've got 148 children. And I've got to divide them into equal groups. So I'm, again, going to use division and see if this works. 8 into 14 will go one time, and that's 8. Subtract, and I get 68, and that will go, 8 times 8 is 64. Subtract, and I have 4. So I have a remainder of 4. Alright, so if I have 8 spaces and 148 kids, how many kids would be in each space? Well, if I do this, that means that they're not going to be equal. I'm going to have 8 I'm going to have if I only have 8 spaces, then I'm going to have, in 4 of those, I'm going to have 18 kids, and in the other 4, I'm going to have to distribute these 4 leftover children. I'm going to have 19 kids in those. So I've got 8 total, but I've got to divide the kids as evenly as I can. And so the 4 boxes, the 4 spaces plus the 4 spaces is 8. And 4 times 18 and 4 times 19 would give me a total of 148. Okay? Go ahead and work your 30 problems in the lesson set, and I will see you